The struggle by developing countries around the world to find a cure for COVID-19 as well as sufficient ventilators to treat patients became intense in the months following the onset of the pandemic. As medical researchers study to find a cure, inventors around the world are also working to ensure that the equipment to treat patients are made available. One of such efforts is being undertaken by the head of Department of Computer Engineering, University of Maiduguri, Northeast Nigeria, Dr. Abdulkadir Alkali, who led a three-man team to fabricate a ventilator.
These ventilators, even in the so-called developed countries, are now in short supply. So they were also forced to come up with easy and simple means of mass producing this important equipment. What happened is this. In our laboratories, we have obsolete equipment. We have PVCs lying down. So there's something called a silicone resuscitator. It's also called an AMBU. The AMBU takes in air from one side, and then when you press it, it expels the air in one from another opening. And when you guide this air into that person's mouth through some tubings or through the nose, so when you press it, the air it gets pumped to their lungs, and then it provides the needed oxygen. So when you release it, the person can now exhale. In some rare instances, very extremely rare though, you'll need to also extract that air from that person's lungs. But what we are dealing with is the assumption that the majority of the cases whereby it just needs to supply air into their lungs.
The ventilator, which was made from recycled materials, is unique from the ones found in the market. It further addresses a unique problem.
Now, we also understood that the air volume that the lungs take vary. So for adults, it can be up to a liter. But for when someone is sick, the lungs take 1 liter. So we took both considerations into perspective, and then we created this using microcontrollers, and then servo motors and everything that we needed. And we used the PVCs, like I said earlier, and came up with the robotic arm, and then the control, and then a display. So what happens is when you switch it on, it will ask you the number of cycles you want in a minute. So once you input that, or number of cycles using a simple knob that we also designed, then it will ask you the number, the volume of air that you want in and out of the lungs.
When asked what plans the team had for their product, this is what Dr. Alkali had to say.
We'll keep improving on this. There are things to look at. The improvement at the moment we are looking at is the air that we're using is the normal everyday air, which has about 21% of oxygen, or you could use 100% oxygen when you connect it to a tube. However, what we want to do now next is to try to have a percentage of oxygen in the air. So we may want to have just 30% of oxygen or 40%. So we want to move forward into doing that. Then while doing that, we'll also try to see if we could evaluate it and then to have approval for its usage anywhere. And I think that's the first major steps that we want to take. And what happens next, I can't say because it's dependent on many, many things. So we'll just wait and take things one step at a time.
The role of rapid innovation and implementation of technology in the fight against COVID-19 cannot be overemphasized. Governments around the world are doing what they can to support the advent of these technologies in order to acquire more resilience against the pandemic. Antonietta Kalunta, AD4 TV Radio, Abuja.